G'day guys, I've got this Garrett Axiom here, and I'm going to pull it apart a bit. A very small T6, so it's a T6 tool that we're going to use to undo these tiny little screws. Don't know what you're going to see, but yeah, it's got the camera sort of zoomed in on this spot here, but I can't see what's going on, so maybe just see fat hands all day. Yeah, so we'll see what's in here anyway. I don't really know much about it. I'm going to definitely flick. Damn it, I put the tripod in front of my tool drawer. There's some nice little pointy tweezers here. Get in here really close, and hopefully this is an upward. You won't be able to see anything because my hand's going to be in the way. Can't do anything about it. There we go. It's a flip window, flip up, and the screen mylar is under that. So the black part does this. Thus, that is out. Thus, out comes the circuit board, and the display is behind this plastic. We have some switches here, just conductive plastic by the look of it. I will check. No, they're membrane switches. They're like a little piece of alloy or some sort of maybe very high tensile tin or something, just a little thing like that, and you poke it down, it makes a contact. We have this shield, which I undid, but hang on, we're going to check in there and see how it comes out. Okay. It's got some folded metal in there. I think it's just a clip. I think. He who thinks. There you go. Just take the pressure off, and this part comes out. It is a shield. So let's have a look. Well, there's a few bits and pieces on the board. Not much on that side. Just these membrane switches, or whatever you want to call them. Clicky tactile switches. Okay, now I'm going to stick my head right in here and have a good look. And yeah. I think it might have had a sticker on there. Dear me, what do we got in here? I should have had the iPad in here. That looks like a high-speed analog to digital converter. A D7768. Let's have a look at the spec on that. Let's get over. Damn, I'm using the Mac to upload other videos. I've just done before and after 5,000, just to show you the difference. Let's doing its bizzo there. I'm just going to go get the iPad. I'll be back in a second. Okay. Okay, back again. So you've probably all looked it up before I've even got the iPad back. Just double check this again. AD7768-4. -4, there we go. We'll have a read of it. I've got the iPad flicking up. 4-channel, 24-bit simultaneous sampling ADC. Power scaling, 110.8 kilohertz bandwidth. Righto. Okay. I'll keep my comments to myself, but it's not, when you look at it, it's not that fast. It's 256 kilosamples per second maximum per channel. It's got 108 dB of dynamic range, which is not too bad. 110.8 kilohertz maximum input bandwidth. 3 dB point. Where are we? Total harmonic distortion, minus 120 dB. Pretty good. Plus or minus 2 part per million of full scale range. That's for linearity. Plus minus 30 ppm of gain error. All the rest of it's pretty interesting enough. Just having a look at power supply requirements, 5 volt and 2.25. Probably that's for the reference voltage, is it? No, it's not. Oh no. How is it? This thing can run 2.5 volts to 3.3 and also run on 1.8 by the look of it. Anyway, I have to read all the documentation. I'm just having a look. So if you really want to know how good the ADCs are, these things, always have a look at how much the price is. If it's here, where it is, evaluation board. I'll probably go and pass the prices, haven't I? Documentation. Recommended for new design. Sample and buy here. Oh, there we go. There's the price there. 1,000 off, $13.23 US. Okay. Well, that might be one worth keeping note on. The main CPU in there. Got a sticker over it. I have no idea what it is unless I remove the sticker. But we'll just have a look at some of the other chips around the place. It's been washed in a solvent, and it's half covered and half not, where it's dried off on the chips. Okay. A lot of LMC stuff in there. I always look at what's that there? There's another little PIC chip in here. That is a PIC chip. There's other little ones here, little square ones with small legs. What are they? They could be. God, I can't read the writing. I really need to clean it up with some isopropyl to read it properly. Okay, it's looks a little bit more intricate than when I first thought. It's really difficult without a schematic when you're just having a look around and trying to get an overview of how this thing functions. And interesting, it's got a big the NPN bipolar transistor here, and it's got a MOSFET there. I'd say the MOSFET's doing the transmit switching, and the big bipolar, is it possibly some sort of active damping? I don't know. What's the spec on an MJE 15031G? Top of my head, I don't know. I could look it up, of course, but yeah. Okay. There's lots of little tiny things in here with multiple legs, like 20 legs and stuff like that. Very, very small. About the match head size with lots of small little legs. So anyway, that's what's in it. That. Now, someone did send me a screenshot of an Axiom price list, and it was very much different than what I saw on eBay when I sort of went, wow, that's so expensive. And the person that sent it to me, well, there it is there. Now, I don't know, shopping, Google shopping, I don't know if it's US dollars or Australian dollars, it doesn't say. But there you are. There it is there. And 1,999. So whoever's had the price up on eBay was probably having a lend of everybody, or wishful thinking or something. I have no idea the pricing. There's a whole package there for 3,144, and it basically, that's an Axiom light. So obviously it just comes with one coil. This comes with a few bits and pieces, but still a massive price difference. I don't understand. You know, coils aren't $1,000. Well, some coils can be, or are sold at that price. But yeah, so yeah, I think let's have a look here. I think I've seen that name who sent it to me before. I'm not going to say too much, but they can damn well probably see it there, can't you? But anyway, yeah. Thanks, Art. Yeah, so they're not that expensive, well, here, but this is only a screenshot, so I can't click it and find out more about it. But anyway, there you go. That's as much I know about this thing. So what I've got to do now is I've got to stick power supply on it, stick a coil on it, and see if it actually does anything. I'm going to put the display back in. Yeah, I'm just having a look. See, the shielded area down here, I think it's a lot of power supply, is it? It's a lot of trimmers, which we will never touch in a million years because we don't know what they are. You've got no idea what they are. So there's trimmers there. I'm just looking around for inductors, but you know, the only inductor I can see on the whole thing, there's a little tiny crystal oscillator there. There's an inductor there, an inductor there. So power supply's up the top. So maybe, oh, I don't know, is this the receive area? It's very hard to tell because I don't have a schematic. You have to sort of empirically try and work it out. I'm just trying to look for LMC 667, LMC 662, I think. Something there. I can't read it. It's got dried gunk all over it. Not gunk, but it's had a clean in a dipping tank, and Yeah, it's all dried on there as it's. I mean, what are you? Oh no. Unless you put a resin over it, that would explain that. The analog devices, look, it could be a 797 in here, that one there, but I can't read it. I'm going to scrub it like as best I can. I only use an isopropyl on it. I'm not going to go and hit it with the heavy chemicals. So let's have a look now. It's amazing. It's just no matter what way I hold it in the light, I can't read it. A D smudge. Okay. Oh, I've seen a problem. Hang on a sec. I've got to get some decent cleaner, but I've seen a problem. I've seen a part in there that's it's been crispied. Okay. So I'll find out what the part is. It's in the receive section, so it's probably some sort of thing that's failed because it's had the damping fail or a high voltage spike has come through. So, oh my god, I can nearly see it. I think that there is an AD797. 797A. There you go. When I get it wet, I can read it. When it's dry, I can't. So I just do that with that. It says AD797A. So there's your input stage there. And right next to it, I've got one of these SOT 23s with two burn marks on it on each side near the legs. I'll just make sure. I think it looks like burn marks. Yep. They're not coming off in a few years. No. They're cooked right there. So this component with no marking. I'll just get the meter out. We'll just see what it is and what it was, possibly. Let's put it on diode test range. We'll just see if it's shorted, open, or whatever. Let's stick the meter over there. You can read it. Okay. Definitely there. Okay, this might be it might be a BAV99. It might be the remains of a BAV. You'll see, well, that was reading a diode junction, and well, it's not a BAV99 because they have two diodes and it goes anode cathode in a clockwise rotation, if you want to look at it that way. So I'll just go back on. I'll just change polarity and have a look. And nothing. Nothing. Was it a transistor? There you go, 0.77 here and nothing anywhere else. So whatever that is there, we're going to find out what it is. If anyone's got a Axiom, you can right next to the AD797 there, you can tell me what that part there is. It's two burn marks through it. So it could be a little MOSFET or something like that. I don't know. I haven't got a schematic. So probably nutted out by looking at all the schematic. It's got a couple of very small. Well, I'll tell you what it is. I'll just do it logically. Okay. We'll say okay then. We'll have a look at the non-inverting input here. I'll get on there. Nothing. Nothing. Okay, let's get on the output. Don't slide off. Okay, It's on the output of the AD797. That's that one there, because that is connected into this part of the circuit. So the gate of this is connected to, I'd say it's a gate or the base, or is it a diode? It's actually connected up through there. Okay, there's a capacitor there, resistor there. Let's check the resistor. It goes to anode. The other end of the resistor goes. There we go. It goes to the inverting input, so that's our part of our feedback network. And if I go on there, you see you nut these things out. So we'll go on diode range, off diode range, sorry. And I'll tell you that get on there. It's being silly. Come on. How much gain are you running on this thing? Wow. Well, the feedback resistor is close to 1.5K. That's a bit out there, isn't it? Can't be that high. I'm trying to find out where they go. That one goes there. Okay. Okay, that's 100 ohms. That would definitely, hang on a second. I want to check this out. I'll put it back into beat range so I can listen without touching. So that goes there, right? It goes to the inverting input. And the other end, I thought it would go to the output, doesn't it? It may go to ground. Wherever ground is, where's ground on this thing? Well, that's negative. I take it the shield is ground, at a guess. Okay, that's ground. And so this is the yeah, she was 100 ohms. That's very strange. It runs off into these devices here. I think it might have switch gain or something, or active gain feedback system. Now that there definitely has 2 Cook marks for it. So we know that this top device here goes to the AD797 on the output, runs back through here into the gate. So I'd say it's either a gate or I don't know what it was because it's burnt. So the black crispy here goes onto the first leg of the black crispy, and yeah, either collector or drain goes down to this one here, which then runs back into the feedback network through that resistor. Can't see any track work, goes through the board and back into here. I'd actually have to draw it out and measure everything to do it on paper, make up my own schematic, because it's not particularly standard. It may be, but they're definitely using active switching, blocking the flyback, because there is no pedestrian type 1K resistor and 2 diodes. There's nothing to dissipate large amounts of power resistively, unless they're doing it through this bipolar. But depending on the spec of that, I don't know, 15031. It might be a very high voltage one. Maybe I should just have a look. If it's got a very high voltage transistor in there, you'll know damn well it's something to do with a flyback, something to do with flyback. Anyway, let's have a look. I'm only guessing this circuit because I don't know. I've got no schematic. So MJE, and it was a 15031. And what is it? Give me a spec sheet, please. Well, it says it's made by onsemi, probably a few of them. Okay. Yeah. Oh, that's interesting. A15031. It's a PNP transistor. Rated for 150 volts DC. It'd be on a bit of an edge there. What's taken the flyback down then? So I don't know. Maybe not. You know what I could do is I could fire the damn thing up and then I measure it and see what's going on. But yeah, it's only 150 volts. So I don't know. You know, you look at these things and there's you get these things designed by 10 different designers, you'll get 10 different designs. So on that, depending what goes to where on what pin and how it's all switched, we can probably work it out. So, and on that note, I don't think I'll do a video of poking around because all you're going to see, because I'm going to have to hold the oscilloscope probe and it's going to be, all you're going to see is this. You won't see anything. And I don't want to keep calling it out what it is because in some cases I'll probably get it wrong and then I'll have to correct myself as I delve deeper. But for the fellow that did say, oh, I want to know more about the Axiom board, well, there you go. That's it. There's, yeah. You can probably work out the parts. If you have a look at the ADC, there's probably the most expensive thing there. It's $8 US or something. But anyway, you get an idea of this. It just costs a lot of money to design it. That's where the money goes. It gets sunk into the design, and you got to try and make your money back. So that's it. That is it. Anyway, there's something fried in there. Anyway, I'm going to work out what's going on. Maybe it fires up and just got no signal. So I'll work it out. Anyway, not going to keep waffling on. I will, kill this. I've got another new device in too, which I'm going to do another video on. And I've got two at the moment going up, which is a 5,000 before and after. So there's heaps of things happening. So you're seeing that? That is it. So yeah, if anyone knows what the device is next to the AD797, the middle one between the other two SOT23 packages, that'd be really good because, like I say, I've got no service information on this whatsoever. And the only service information I'll ever get is if I sit there and I nut it out myself around, with the oscilloscope, the thing powered up, and try and work out what's doing what and just draw it out. That's probably the easiest way. That's how I've done it many times. I've had to, back engineer stuff and try and work out what's going on. Anyway, good enough on this. I hope it is anyway. I can't really do much more until I work it out, and I'll tell you all about it. Catches.